In the previous lectures, we talked about how to use Python for economic and financial analysis using pandas, and also numpy, the two major libraries that are used in this space. But it was pretty abstract and theoretical. We talked about Python syntax, and it was hard to get a sense of why any of that is useful. And so in this discussion, we'll actually apply the things that we've learned before to a real data set. We'll be using a data set from Airbnb that shows the price of Airbnb properties in Toronto. It's a real data set. It's got quite a few observations. We'll talk about how many when we get into it. The other thing to note here is that I'm not using the SageMaker machine learning tools, so we're going to be doing linear regression. SageMaker offers linear regression, or a tool called Linear Learner, which is a fantastic way for developing machine learning models and also deploying them. What we're looking for here is just a statistical analysis of the relationship between variables. I'm not going to be deploying anything at this point, so I'm going to keep it simple and use a different Python module for that analysis. We'll accomplish kind of the same thing as far as the answers will be the same values, but it's a little bit easier in this context to just run it in a notebook instead of using all the power that we can get behind SageMaker, since it's not needed in this instance. So I'll begin by opening up the notebook. Since Python can do so many different kinds of things, it can make websites, it can make games, it can do data analysis, we need to begin by telling Python what we're going to do. And the convention is to import pandas and numpy as the first thing we do. And also to give them these aliases. This is what you'll see in all of the notebooks from data science. Import pandas as PD and import numpy as NP. It's the very standard thing to see. And then we'll use this method from pandas to read our CSV. And we'll save it as df. That's an object that we're creating that's going to be a data frame. The data frame will hold our data, and you can imagine a spreadsheet that it's taking this information and it's going to hold it in memory so we can do our analysis. I'll hit shift and then enter, and it worked great. It gives us an error here, and we'll talk specifically about what this means in a moment. But let's take a look at our data. So it is 106 columns wide. Let's see. Just created a new cell block here just to get a sense of its overall. Do df.shape. All right, and it's 22,425 rows. It's the total size of our data frame. It has some things here that we're not going to use for our analysis. The URL listing, the scrape ID, when it was scraped, and some other stuff. So we don't need that. So let's just remove that from our data frame since we're not going to use it. I'm going to create a list of the columns that I want to drop. So the columns I want to drop in this case are listing URL, scrape ID, and last scraped. Then I will say, take my data frame and apply this method. That's what happens here. Take my data frame and do this thing. So drop, I'm going to pass in some parameters. The first one I pass in is which columns I want to drop, which is this list. The second thing is which axis to use. For a data frame, axis 0 is a row and axis 1 is a column. We want to drop these columns out and kind of remove them completely from our data set. The last thing is in place. So we could say df equals df.drop, and we would be creating a new object. We'd be taking our data frame and then saving it again. But this is more energy or memory efficient, so we're just going to do it to the original data frame. I'm not worried about the fact that I'm saving these back as the same thing, since we're not going to need these columns again at all in our analysis. If there's a potential that you might want to use them, you could save it as, say, data frame 2 or data frame 3. Then you could reference different ones. But for what we're doing, it's going to be just to drop them. All right. So there are lots of columns. One of them is price. So let's take a look at price. To look specifically at price, I just need to say data frame, and then in brackets, the name of the column. Then I want to apply this method just to this column of data. The method is describe. Describe is telling me the count, the number of unique values, the most frequent value, right? And it's also telling me that my data type, data type, is an object. Well, I didn't want this to be an object. I was really hoping that my price would be a number so that we can do things like find the mean price. And since it's an object, if I do something like try and do a box plot of this, well, it doesn't work because you can't make a box plot of an object, which is a string. Right? So the same thing will fail here. And what we need to do, let's just look at, I used head to see the top values here. You can see that they contain a $, and there are some of them that also contain a comma. So we need to remove those and then recast this column. So change this column from being a string into a floating point number so that we can do analysis. All right. This is a very common problem that happens when you take data from Excel and then save it as a CSV. It can be saved as a string, and so those things like the $, and comma get carried along with it, when in fact what we're looking at is just a number. So I'm going to take my column and replace the $, with nothing. And then I'm going to do the same thing again and replace my comma with nothing. The last thing I will do is to cast this as a float. So instead of having it as an object, I want to make it a floating point number. And now I can make a box plot because now it's a number. The base box plot here is really hard to read. So there are values that go from, it looks like 0 all the way up to 14,000. There are some properties in this data set that are $14,000 a night to rent. But those are clearly outliers. I'm more interested in what is a normal price for a property on Airbnb. And so to do that, I'm just going to narrow down, apply a filter basically, to places where the column of price is less than or equal to 300. And then make a box plot of the column price. There we go. That looks much better. Now we can see the mean. The median here looks like it's about 100. I've got a spread that goes from 0 to about 275. Great. We can also see this as a histogram distribution of these values. Very good. If we wanted, we could save this to a CSV. So to do that, we would say take our data frame and apply this method to CSV. So save to CSV, and then tell it where we want it to save. And it will do that for us. Done. Great. So now let's start to ask some questions of the data and find the answers.